So this was from Friday, and we already filled out this part. We graphed the parent graph on Friday. Just a quick review in case you forgot. We made an XY table on Friday, and we plugged in 0. And when you do 0 squared, you get out 0. When you do 1 squared, you get out a 1. When you do 2 squared, you get out a 4. When you do 3 squared, you get out a 9. And if you go to the negative direction, plug in a -1 and you square it. -1 times -1 is also a +1. Plug in -2, you also get a +4. Plug in a -3, you also get a +9. And when you graph that, you'll get this. And the blue ones, and that's pretty much our parabola. If we draw a line, now you guys should have already done this on Friday. If you weren't here, then you should follow along right now. So this is our parabola. And the parabola really does go this way forever, and it goes that way forever. What do I mean by that? I could plug in a 10 and go 10 squared. That would give me 100. So at the location 10, my output's 100 way off the paper. But it still exists. Anyway, the vertex was, in this case, the 0, 0, the origin. And the axis of symmetry is the vertical line that passes right through that vertex. So anyways, that's the graph. That's what we did on Friday. We could have found the vertex using the vertex formula. We already know the vertex is 0, 0, but you could have done your A value is 1, your B value is 0, your C value is 0, right? You could put a +0x +0 if you want, but that would be pointless, but you could if you wanted to. Let's jump to over here where we have the actual steps. We're always going to start by finding the vertex. So let's look at this example. And the very first thing you should all write is the word vertex. And do a coordinate right below that word vertex. And how do we find that vertex? We use the formula x equals -b over 2 times a. So let's use the formula, but let's rewrite it with parentheses instead of the b and the a. And now let's identify our a is -3, our b is 6, our c is 5. And we're plugging in 6 for b and -3 for a. So for our x value, we really have a -6 over -6, which is what? What's x? What's -6 divided by -6? +1. So we know that x equals 1, and that's the vertex. The x value is 1. Let's find the y value on the vertex. Once you know the x, how do you find the y? You plug it in. So I'm going to rewrite this original equation. I'm going to rewrite it, but plugging in the 1 into the x's with parentheses. So let me make a little bit of space and rewrite it over here on the side. And of course, I'm going to plug in the x value of 1 because that's what x is. X is 1. And all you have to do is the math. But of course, you have to use the correct order of operations. So we're going to start with exponents because the parentheses, there's nothing to do in them. Start with exponents. 1 squared is 1. So you really have -3 times 1, that's -3. You have 6 times 1, that's 6. And you bring down the 5. So you really have -3 plus 6, which is 3, and then 3 plus 5, which equals 8. Now we just found that the y value is equal to 8. So the vertex, we found the x value of 1 using the formula, and then we plugged it in, and we found that the y value is 8. So the vertex, the most important point is 1, 8. Let's all go to 1 on the x and 8 on the y and put a dot. Wait, right there. Put a dot right there. And that point is the vertex. The coordinate 1, 8. Now, what is step 2 on graphing a parabola? You draw your vertical line right through the vertex. That vertical line is called the axis of symmetry. So I'm just going to draw a vertical line right through that vertex because that's going to provide a reflection to both sides. So I jump to I need more coordinates. How do I get more coordinates on any graph? By going to an XY table. So let's plug in some values, but if somebody could read me step 3 up here, this is what the step we're on. We're gonna do what? Okay, so let's start with the first half. We're going to plug in 2 numbers on the same side of the axis of symmetry. So could somebody give me two numbers that are on the same side of the axis of symmetry? Okay, how about this? What value do you think is the easiest number to plug in? The absolute easiest. 0. Whenever you plug in 0 into a quadratic trinomial equation, your output is going to be the C value 5. I mean, think about it. 0 squared is 0, negative 3 times 0 is 0, 6 times 0 is 0, 0 plus 0 is 0, 0 plus 5 is 5. So I'm going to go with that easiest number, 0, and I'm going to get out a 5. Let's graph it. I want to graph this in red. 0 on the x, 5 on the y, 1, 2, 3, 4, 5 right here. Are you with me? Okay, so I need another point. We just said on the same side of the axis of symmetry. So this number that we found, is it on the left side of the axis of symmetry or the right side of the axis of symmetry? Left side. So I need to plug in another number on the left side of the axis of symmetry. Like some people will say plug in 1. But that's no good, right? Because we already plugged in 1 when we found the vertex. The vertex, we found the x value was 1, we plugged it in and we got out an 8. So if I were to plug in a 1 again, I would get out an 8 again. That'd be a total waste of time. Now we said we want both dots to be on the left side, over here on this side of the axis of symmetry. So if we already plugged in 0, let's plug in negative 1. Okay, so let's also plug in a negative 1. Let me do it over here in red, negative 1. If I do plug in a negative 1, let's show our work over here on the side. So you rewrite your equation, but with parentheses instead of the x's, right? Parentheses instead of x's. Let's plug in the negative 1 right in there. So put a negative 1 here, a negative 1 there. Let's do the math. We're going to use PEMDAS. Negative 1 squared is positive 1. But I still have the negative 3 out here in the front. Let me bring down everything else so we don't get confused. The plus 6 times negative 1 plus 5. So when we do the multiplication, negative 3 times 1 is negative 3. 6 times negative 1 is negative 6. Bring down the plus and the 5. Let's add and subtract from left to right. Negative 3 and negative 6 is negative 9 plus 5. X or y equals negative 4. Y equals negative 4. So we found the y value of negative 4. And let's graph that point. So from the origin, here's the origin. Let's go negative 1, 2, 3, 4, and put a dot right here. Now, at this point, all you have to do is reflect it over to the other side of the axis of symmetry, and you're done. So let's map this dot. It's 1 unit away from the axis of symmetry, so go 1 unit this way, and you could map it over and get it there. This other one is 2 units away, so go 2 units away, and you'll get your coordinate right there. Now all you have to do is draw your parabola right through those coordinates. Get it? So once again, first step was to find the vertex. How do you find the vertex? You use the formula x equals negative b over 2a. You're going to get the x value. How do you find the y value? You plug it back into your x positions over here. Do the math using PEMDAS. You get the y value of 8, so your vertex is 1, 8. You graph the vertex 1, 8. You draw your axis of symmetry. Step 3 is to use an XY table and plug in two numbers that are on the same side of the axis of symmetry. Why do I want the same side? Because you'll be able to map these two dots over here with the axis of symmetry. So it would be totally pointless to plug in the number 1 because you'd get the output 8, or even plug in the number 2. If you were to plug in the number 2, you would also get the output 5. How do I know that? Because it's at the same level. It's better to reflect it over than to actually plug in all the numbers. So you could plug in as many numbers as you want, but all you really need is a couple of numbers and then reflect it over to the other side of the axis of symmetry. Let's look at the last example down here. This one down here, let's find the vertex. Vertex is a coordinate. It has an x value and a y value. I'm going to find the x value by using the formula negative b over 2 times a. I'm going to use the formula correctly by replacing the b and the a with parentheses. X equals negative parentheses over 2 times parentheses. And then I'm going to go back to my equation and identify the a, the b, and the c. The a is 1. The b is what? 0. It's not there. The C value is negative 3. If you wanted to, you could rewrite it like this, like y equals x squared plus 0x minus 3. But we could all see that the b value is not there, so we're going to say that the b value is 0. So I'm going to plug in 0 for b. The a value is 1, so we really have negative 0 divided by 2, which means x equals 0. So we have the x value of the vertex.
As negative 0.
Right, negative 0 is the same thing as 0. So x is 0. Here's the 0 of my vertex. How do I find the y value? Plug it in. What is 0 squared minus 3? Negative 3. So there's your vertex 0, 3. Let me graph it in red. 0 on the x, negative 1, 2, 3 on the y. There it is. What's the very next step? Once you graph your vertex, what do you draw next? Axis of symmetry. That's right, axis of symmetry. So go ahead and draw it right through the vertex. Why do we draw this? Because it's going to give us a perfect reflection from one side to the other. So of course, we need more points. What do we do? McLean, what do we do? We need some coordinates. What do we do? How do I find more coordinates, McLean? That's right, an XY table. Now, I need to plug in two numbers that are on the same side of the axis of symmetry. What should I plug in? Should I plug in 0?
No.
Heck no. Why not? Because we already plugged in 0 on the vertex. It'd be pointless to plug it in again. I'd get out a negative 3 again.
1 and negative 1.
Okay, now I like
1 and 2.
1 and 2. 1 is good and 2 is good because both of those values, see, here's 0 on the x. If you plug in 1 for x, it's over here. 2 for x is over here. They're both on the same side, and that's what we want. We want it to be on the same side. So if I do plug in a 1, let's do this in our heads here. 1 squared is 1, and 1 minus 3 is 2. I mean, negative 2, that is. And if I plug in a 2 right here, 2 squared is 4, and 4 minus 3 is 1. So we get these two coordinates. Let's graph them. Let's go to 1, negative 2. It's right here. Let's go to 2, 1. It's right here. Now, let's reflect it to the other side, which you get a point right here and over here. And that's your parabola. That's it. Put some arrows on it, and you're good. Now, let's say you believe that your parabola is too small. Let's say you wanted to draw it further up. Then you could plug in more values. You could plug in as many values as you want, right? What would be another nice number to plug in? 3? Okay, so if I plug in a 3, what's 3 squared?
9.
And what's 9 minus 3? 6. Okay, so let's go to the coordinate 3, 6. Here's the origin. 1, 2, 3. 1, 2, 3, 4, 5, 6. Put a dot right here. And of course, reflect it to the other side. If it's 1, 2, 3 units away, 1, 2, 3 units away, put a dot right here. Now, we already see the parabola. You could draw it further if you want. I'll draw it further. Why not? Go through those. Put some arrows up here. And we're good. Now, this is what I want you to do. Compare the very first parent graph that we graphed with this one, the parent graph up here. See that U-shaped curve? And you see this U-shaped curve? It's the same exact thing, right? It's the same exact thing. The only difference is that the parent graph has the vertex at 0, 0, and this guy has the vertex at 0, negative 3. But otherwise, it's the same identical U-shaped curve opening up, okay? So let me talk about the A value. The A value, not only does it tell you if it's opening up or down, but it also tells you if it's a wide parabola or a narrow parabola or a regular looking parabola like this guy. Check it out. So the A value is going to tell you if you have a wide parabola or a narrow parabola. Okay, so the A value, if you look up here, the A value of 1, y equals 1x squared. That was the parent graph that we graphed. That's a regular U-shaped curve. All right, the A value of 1 produces a regular U-shaped curve. Now, if I were to take that A value of 1 and make it 1/2, it would actually make it wider. Okay, so again, A value of 1. So y equals 1x squared is right here. Y equals 1/2 x squared would make it wider. If I went 1/4, it would make it wider. Y equals 1/4 x squared would be wider. Y equals 1/8 x squared would be wider. Does that make sense? So let's go back to the regular A value of 1. Here's y equals 1x squared. If I changed it to a 2, what would happen? Y equals 2x squared, what would happen? It'd make it more narrow, more stretched that way. 2x squared, 3x squared, 4x squared. Make sense? So the a value, the closer it gets to nothing, the closer it gets to 0, the wider it gets, right? So let me try that again. Here's y equals 1x squared. The a value is 1. It's a regular U-shaped curve, just like the parent graph. If I drop it to 1/2, y equals 1/2 x squared, 1/4 x squared, 1/10 x squared. If you go 1/100th x squared, that's hardly anything, right? It's almost 0. It's going to practically look like a flat line. If you actually get to 0, if you say y equals 0x squared, that means that you don't have a quadratic equation anymore. It'll just be a flat line, okay? So the a value doesn't just tell you if it opens up when it's positive or opens down when it's negative. It also tells you if it's wide or if it's narrow, okay? The closer you are to 0, the wider it gets. The further you are away from 0, the narrower it gets. So if I told you this, y equals negative 5x squared, negative 5x squared, y equals negative 5x squared, would that be opening up or down? Down. Would it be wide opening down, or would it be narrow opening down? Y equals negative 5x squared. It'd be narrow, right? Okay. What if I said y equals negative 1/10 x squared? Would it be opening up or down? Down. Would it be wide or would it be narrow? 1/10. It'd be wide, right? Opening down. So the a value tells you a lot. Not only does it tell you if it opens up or down, but it also tells you if it's wide or narrow. Thank you. So with that said, guys, this is the reason why this graph that we just did is identical to this one. It's just moved into a different position. It has a different vertex, right? So, ladies and gentlemen, any parabola that has the a value of 1, any parabola that has the a value of 1 is going to look exactly like this. But it might be located somewhere else with a different vertex. Or it might be opening down. But it's going to be exactly this perfect width of a U-shaped curve. Okay? Now, this is what I want us to do. I want us to look at the XY table that we had. And like I said, any parabola with the a value of 1, it's going to have this pattern. So I need you guys to circle it, highlight it, I don't know, box it in. We need to understand that this is a very important pattern. The pattern 1, 1, 2, 4, 3, 9. We're going to memorize it, right? 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. Okay? Why do I want you to memorize it? Because anytime you see a equation that has the a value of 1, or negative 1 for that matter, you'll know that once you find the vertex, now right here the vertex is 0, 0, so that's pretty easy. But from the vertex, you're going to go 1 over 1 up, and then you go back to the vertex and you go 2 over 4 up. Then you go back to the vertex and go 3 over 9 up. And then once you have those points, you can just map them over to the other side and you'll be done. So if you know that the a value has the pattern 1, 1, 2, 4, 3, 9, you'll be able to do the problem in a minute or two as opposed to 5 minutes. So let's go back to this one. Let's pretend that we found the vertex doing this math, and then we plugged in 0. We plugged in 0 to find the y value, and we got 0, negative 3, and we go to the vertex, which is 0, negative 3 right here. Now, let's pretend I didn't want to make an XY table. Then I could use the pattern that I just asked you to memorize. What's the pattern? 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. Okay? So from the vertex, check out, here it is. There's a vertex. From this vertex, if you go 1 over and 1 up, you get to that coordinate without doing any math. Then you go back to the vertex and you go 2 over, 4 up. You get to that coordinate without doing any math. Then you go back to the vertex and you go 3 over, 9 up. You'll get to that coordinate without doing any math. And then you just map it over to the other side, map it over to the other side, map it over to the other side. You have your parabola without doing much math. Does that make sense? Yes. Isn't it awesome? Yes. Could we use the pattern on this one above? No. Why not? The a value is not 1. The a value is a negative 3. Okay. Now I'll show you later on how to force the pattern when your a value is different. But right now I just want you to practice that pattern when your A value is 1. Let's flip it to the back side on the homework. Again, you could use the pattern 1, 1, 2, 4, 3, 9 on any parabola that has the A value of 1 or negative 1. So I want to jump to the one that says number 2 on the left side, and I want to start with my usual steps. Step 1, find the vertex. How do you find the vertex? It's really a coordinate, and you're going to use the formula x equals negative b over 2 times a. How do you use that? You use it by replacing the b and the a with parentheses instead of the letters. And then you identify your a value, which is what? Negative 1. Your b value, which is what? There is no b value, it's 0, and your c value is 3. So what do I plug into this formula? My b is what?
0.
My b is 0. My a is what? Negative 1. Perfect. So what do we have here? We have a x equals a negative 0 divided by negative 2. It's still 0 divided by a number. And 0 divided by any number is what? 0. So your vertex x value is 0. How do you find the y value? Plug it in. So take the 0, plug it in here. 0 squared is 0. Even though it's negative, it's still 0. And 0 plus 3 is what? 0 plus 3 is what? 3. So the vertex y value is 3. The vertex is 0, 3. Let's go to the xy plane and go to 0 on the x, 3 on the y. Let me do it in red. Sorry. What's the next step after you plot your vertex?
Do the line.
Do the vertex. The axis of symmetry right through the vertex. And now normally we go to an XY table and we plug in some numbers that are on the same side of the axis of symmetry, but I just showed you the shortcut. If your A value is 1, remember the A value tells you if it's a wide parabola, a regular parabola, a narrow parabola. We know that all the A values of 1 is going to have the same pattern as our parent graph. And what's that pattern? 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9 from the vertex. So ask yourself, does my parabola open up or down? Down, because the A value is negative. So from the vertex, I'm going to use the pattern 1 over 1 down. Now, it doesn't matter if you go to the left or to the right. What do you guys want, left or right?
Right.
Right. Okay, so 1 over 1 down, let's put a dot right there. And then you go back to the vertex and you go 2 over 4 down. 1, 2, 1, 2, 3, 4, and put a dot right there. And then you go back to the vertex and you go 3 over 9 down. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm 1 unit off the graph, but that's okay. I want to draw it anyway. There it is. Now I have half of my parabola without doing any math. I didn't do any XY table, right? All I need to do is map it to the other side. What do? Reflect it. So right here it's 1 unit away, so go 1 unit this way and put a dot right there. This other one is 2 units away, so go 2 units this way and put a dot right there. And the one that's off the graph, you'd have one way down here off the graph. Wait, no, I'm sorry. Over here. Let me erase that other one. Sorry about that. And let's just graph our parabola now. And that's it. All we had to do was find the vertex, and knowing the pattern, we didn't have to do any other math besides it. Now, of course, we're going to have other problems where our A value is not 1. So right there, you really do have to find the vertex and then use an XY table, and it's a lot more math. So let's work on this for homework.